So we've got these stoneflies that are moving along a set difference, and we've timed trips in different ways. We have the time it takes for the fly to travel across a set distance with the sails, and we've got the time it takes for it to travel along that same distance without the sails. And the problem is, the first part of the problem is asking us to find the ratio of the sailing speed, Vs, to the non-sailing speed, Vns. So we're looking for a ratio, so we can set this up as a division. So we're looking for the ratio of Vs to V sub Ns. So it's just a simple divisional fractional problem here. So we are given the times for both of the trips that have been measured, and the only thing we're told about the distances is that the distances are equal, since it's explicitly stated in the problem that it is a certain length that is being traveled. So we recall that speed is equal to distance over time, so we can expand on this ratio a bit more by, instead of saying V sub s, we can say d over t sub s, and then instead of saying V sub ns, we can say d over V sub ns. And again, the reason why I haven't given unique labels for the d's is because we know they are the same, which means they can cancel out with each other by division. And then we can simplify this formula a bit further by bringing our t sub ns into the numerator and the t sub s into the denominator. So this becomes t sub ns divided by t sub s. And now we just plug in the times that were given to us in the problem. T sub ns, the non-sailing speed, is 25 seconds. And the sailing speed is 7.1 seconds. Put this into our calculator and we find this ratio to have a value of about 3.52. And that is the answer to part A. Now part B of the problem is asking for a 2-meter path to find the difference between the two times. So we're looking for delta t. Or rather, t sub ns minus t sub s, since we know that t sub ns is going to be larger. And we're being asked to find this in terms of v sub s. So first off, recall that time is equal to distance divided by speed, or velocity. So t sub ns can be rewritten as d over v sub ns, and t sub s can be rewritten as d over v sub s. Now, before we go any further, let's note that the problem specifically asks us to find our answer, to find our time difference in terms of v sub s. So our final answer should have v sub s in the answer, but it should not have v sub ns. So let's use the ratio we found in part A to get rid of the v sub ns variable in our current math. Now the ratio we found in part A tells us that v sub s is equal to 3.52 times v sub ns. That means that v sub ns is equal to v sub s divided by 3.52. So we can incorporate that into the math we're doing right now. We can say that d divided by v sub ns is equal to d divided by, and instead of saying v sub ns, we'll say v sub s divided by 3.52. And then we're still subtracting d over v sub s. To make this a little easier on the eyes, let's bring the 3.52 into the numerator. So that's 3.52d divided by v sub s minus d divided by v sub s. We can simplify this even further because the denominators are the same and the numerators both have a d. So this is basically saying 3.52d minus 1d. So we can combine them together by saying 3.52 minus 1, that's just 2.52d, divided by v sub s. So now we've got a pretty simple formula here, and the problem tells us that we're looking at the case where the distance is 2 meters. So 2.52 multiplied by 2 meters divided by v sub s. Put this into a calculator, or just do the math, and we find this time difference to be 5.04 meters over v sub s. And that is the time difference. That is the answer to this problem. That is it for this problem. I hope this video helped you out. If it did, please consider subscribing, as that'll help me out in making more videos just like this. If you have a request or a question, leave a comment down below, and I'll do my best to help you out as best as I can. That's all for now, and I hope you all have a lovely day. Bye-bye.